7.3 Using class decorators. We're going to see how to use class decorators to programmatically add, remove, and modify the attributes of a class, wrap a class in generated code, or even use the class as structured input data for declarative programming. Class decorators work in the same basic way that function decorators do. A class decorator receives a class as its only parameter, and whatever it returns replaces that class. The return value doesn't have to be the same class, or even a class at all, but it should be something that is meaningful when it's bound to the class's name. It's rarely useful for a decorator to return none. Also, like a function decorator, a class decorator can modify the attributes of a class, or enclose the whole class in a wrapper code. However, modifying the attributes of a class is effectively the same thing as modifying the class's source code, which means that, unlike with functions, a class decorator can actually alter the structure of the decorated code, not just wrap it. Modifying a class is straightforward. We just use the built-in getAttr, setAttr, and delAttr functions, or hasAttr if we want to check for the existence of attributes. In this example, we see a simple class decorator that adds a getItem operation to a class while removing the setItem and delItem operations, so that getting an item is equivalent to getting an attribute, but setting and deleting are forbidden. While rewriting classes via decorators can be a powerful technique, it's not a complicated or surprising one, so there's not much more to say about it. We can also wrap up classes in their entirety. One common use for that technique is to replace a class with a factory function. Using a factory function as the interface to creating class instances lets us choose to return an existing object if there's one we think is appropriate, rather than creating a new instance. Calling a factory function means give me the right object for these parameters, rather than give me a new object for these parameters. Let's take a look at an example class decorator that replaces the class object with a factory function for instances of that class. We'll assume that any two instances that were created using the same parameters should actually be the same object. In this example, we're using a weak value dictionary to keep track of the existing instances of a class and what parameters they were constructed with. That doesn't have anything to do with the class decorators per se. Instead, we're doing it because we don't want the cache to prevent the instances from being garbage collected. That's a good practice whenever we make a factory function that keeps track of the instances it creates. Another bit of good practice that we're demonstrating here is that we've assigned the class itself as an attribute of the factory function. That means that code outside of the factory function can still access the class object if it really needs to. So let's take a look at our factory making decorator in action. Notice that the thing named unique is in fact the factory function that was created for the unique class rather than the unique class itself. The actual class ends up being named unique.type. Also notice that u1 and u3 are not just equal, they're actually the same object. u2, meanwhile, which was created with different arguments, is a different object. Now we're going to take a look at something really wild. The syntax we use for defining classes is pretty generic. It could be used to represent all sorts of structured data. So why not use class decorators to transform class definitions into structured data objects? But by doing this, we can achieve a sort of sideways declarative programming paradigm. For example, let's say we want to connect to a SQLite database, and we want to create some tables in it if they don't already exist. We can make Python's class syntax work for us as a convenient way of expressing that idea, as you see on the screen now. We want the usage to look something like this, where the class structure and attributes provide the information that's needed to construct and configure a database connection for us. The end result should be a connection object, which we can use to issue queries according to the Python database API. There are a great many details that are ignored or handled simplistically in this example, but it captures the general idea and it works. The class objects that Python creates automatically when it's evaluating these statements. The class objects that Python created automatically when it was evaluating the statements you saw in the previous example are used to provide structured data input to this decorator, called database, and then discarded. The database decorator returns an open Python database API connection, not a class of any sort. So class decorators are functions that take a class as their only parameter and return, usually, a class. A class decorator can add, remove, or replace class attributes. The return value replaces the original class, even if the return value itself isn't actually a class. Class syntax can represent a wide range of structured data, so with the right class decorator, we can use it for declarative programming. That's the end of our discussion of class decorators. In the next video, we'll look at metaclasses, which are another way of manipulating the semantics of classes.